Game development, bounce off the walls. This is the third step out of the 10 of the game dev canvas tutorial, and in the previous video this is pretty much what we did. So we're having this wall, but it's not bouncing off, so we're gonna work on it, and this is pretty much the code in GitHub if you want it. So this is the link also. Okay, so you can find the source code as it should look after completing this lesson. So you can click here and it's gonna give us this code. So we have that. It is nice to see our ball moving, but it quickly disappears from the screen. So they're talking about this one. So if I refresh it, okay, it's moving, but it quickly disappears from the screen. So we wanted to bounce off. Okay, so disappears from the screen, limiting the fun we can have with it. To overcome that, we will implement some very simple collision detection, which will be explained later in more detail, to make the ball bounce off the four edges of the canvas. So simple collision detection. To detect the collision, we will check whether the ball is colliding with the wall, and if so, we will change the direction of its movement accordingly. So to make the calculations easier, let's define a variable called ball radius that will hold the radius of the drawn circle and be used for calculations. Add this to your code somewhere below the existing variables declaration. Okay, so we are gonna go into our JavaScript. So let me see. Okay, so to make the calculations easier, let's define a variable called ball radius that will hold the radius of the drawn circle. Okay, add this to your code somewhere below the existing variable declaration. So below the existing variables, and these are the okay, so these four are variables and these two are functions. So we're gonna go below here, and we are gonna pretty much have this constant declaration. So we have four let statement declaration. This one is gonna be a constant, and we're gonna name it ball radius, like that. And again, remember camel notation, ball radius, and we are gonna set it to 10, and this is a constant, so it's gonna keep it, we're gonna just keep it 10. And again, if I refresh it, nothing's gonna happen because we still haven't called it or whatever. Now update the line that draws the ball inside the draw ball function to this. So, and again, here we have, in the previous video we updated two functions. We have the draw ball and the draw. Okay, so we're gonna work inside of the draw ball function. Now update the line that draws the ball inside the draw ball function, and we are gonna pretty much just add, let me see, so we have x, y, 10, 0. Okay, so we're gonna update it. So we're gonna have, instead of having 10, we are gonna have just the ball radius. So we're gonna call it, okay, so I have it here, save it, and now let's refresh it. So okay, so nothing's happening yet, but okay, so we have the ctx arc, then we have xy, then ball radius 0, math.py multiplied by 2. Okay, so we have that up to this point. Okay, so let's keep moving. Bouncing off the top and bottom. So there are four walls to bounce the ball off. Let's focus on the top one first. We need to check on every frame whether the ball is touching the top edge of the canvas. If yes, we'll reverse the ball's movement, so it will start to move in the opposite direction and stay within the visible boundaries, remembering that the coordinate system starts from the top left. We can come up with something like this. So we are gonna have in this statement declaration, but we're gonna do it. So if yes, remember the, okay, so we're gonna have this statement declaration. Okay, there are four walls. Okay, if yes, reverse the wall. We are starting the opposite direction. Remember that the coordinate system. Okay, so we have that, and let me see, they don't say where we are gonna have this if statement declaration. Okay, so we are gonna have it in the draw function. So we have the variable y plus the variable dy. Okay, so we have that. They don't say it, but we are gonna pretty much have this function inside of the draw function here, and let me see, let me just check it out real quick. So we are gonna have it the draw ball, okay, just before this one or after the draw ball. So we're gonna keep it here. We're gonna have this if statement declaration. So we are gonna go here if the y statement declaration plus the dy statement declaration is less than 0. If the sum of the variables y and dy is less than 0, we are gonna do something, and that something is that we are gonna assign the variable dy, we're gonna assign it to the variable negative dy, semicolon at the end. Okay, so let me see, we have that up to this point. Okay, so nothing's changing yet. If y is less than 0, then we are assigning dy, so that's fine. Okay, remember, we can come up with something like this. Okay, if the y value of the ball position is lower than 0, change the direction of the movement on the y-axis by setting it equal to itself. Reverse, if the ball was moving upwards with a speed of 2 pixels per frame, now it will be moving up with a speed of negative 2 pixels, which actually equals to moving down at a speed of 2 pixels per frame. The code above would deal with the ball bouncing off top edge. So now let's think about the bottom edge. Okay, so, and again, if we check out the code here, we can see that okay, so we are checking it right here. This is the y, and then it's gonna be the if statement. So we have the variables y and dy, so we have that. Now we're gonna deal with the, okay, so this one was 0, but this time is gonna be canvas greater than canvas.height. So let me see, we're gonna have with canvas greater than height. Okay, so the code above would deal with the bounce. Okay, so now let's think about the bottom edge. Okay, alright, so we have that if the ball's y position. Okay, so we are not gonna type it out yet, so this is just giving us an example. So we can, let me see, we can just have it like a code here. Okay, or multi-code. Okay, so if the ball's y position is greater than the height of the canvas, remember that we count the y values from the top left, so the top edge starts at 0 and the bottom edge is at 320 pixels, the canvas height. Then bounces it off the bottom edge by reversing the y-axis movement as before. So now we could merge those two statements into one to save one code verbosity, and that is that if, so we are having the if statement declaration if the y variable plus the dy variable is greater than the canvas height, or, so we're using the logical operator, or the variable y plus the variable dy is less than 0, then the variable dy, we're gonna assign it to the negative dy. So that's pretty much it. If either of the two statements is true, reverse the movement of the ball. So now, bouncing off the left and right, we have the top and bottom edge covered. So let's think about the left and right ones. It is very similar actually. All you have to do is to repeat the statement for x and y, for x instead of y. So again, we have this pretty much. Let's delete this code, so we are gonna type it here. It was just an example. Okay, so we have that if the sum of the variables x and dx is greater than the canvas width, or the sum of the variables x and dx is less than 0, then the variable dx is gonna be assigned to the negative dx. So, and then that if the sum of the variables y and dy is greater than the canvas height, or that the sum of the variables y plus dy is less than 0, we're gonna have that the variables dy is set to the negative dy, and that is for the left, for the bouncing off to the left and right. So as you can see, that would be from the left, right, so that would be for horizontal, and this one would be for the, let me see, bouncing off and top for the vertical would be from up, from the top, bottom. So we have that up to this point. It's just some theory that they're giving us. Okay, so velocity bouncing off to the left, right. Okay, at this point you should insert the above code block into the draw function just before the closing curly brace. So now it has to be, again, it has to be in the draw function, and it has to be after the draw ball. In this case they say just before the closing curly brace, or just before the closing curly brace. Okay, at this point you should insert the above code block into the draw function just before the closing curly brace. So okay, we can do that, and if that's what they say, we can do this. We can type it out. This is the curly brace, so we will type our code here, and you can just paste and copy, but it's always better to pretty much type it in. So let me see, it was right here. If the value, okay, bouncing to the left. Okay, so we are gonna start with this one. So we're gonna have the if statement declaration, and pretty much we're gonna have the if the sum of the variable x and the variable dx is less than, or I mean it's greater than the width, it's canvas the width, so it's greater than canvas that width, like this. Or so vertical bar, or the, let me see, it was x, again the sum of x and the variable dx is less than 0. What we are gonna do is we're gonna assign the variable dx, we're gonna assign it to the negative dx, like that, semicolon at the end, save it, and let me see if something is happening yet. Okay, so, and again, as you can see, is when it's touching the horizontal from left to right, is bouncing, but the moment it's going up, it doesn't come. At the moment it goes to the top, it doesn't go back to the bottom. So we're gonna deal with that now. So, and you can copy and paste this. So it's gonna be if the sum of the variables y and dy is greater than the canvas, that it's not gonna be high. I mean, it's not gonna be width, it's gonna be high this time, so it's gonna be vertical. And then it's gonna be, or the sum of the variables y dy is less than 0. Okay, so if that is that, we're gonna have that the variable dy is gonna be set to the negative dy, semicolon at the end, save it. And now if we refresh our work here, is okay, as you can see, it's bouncing. So right now it's tap, it's going, okay, left, right. Now it's going to the, okay, it's moving, this is left, right. Okay, so it's going a little bit faster, but as you can see, it's bouncing from the top to the bottom, and from the left to the right, from the right to the left, and from the bottom to the top. So it's working right now, so pretty cool. So it's working, so we can refresh it and the same thing is gonna happen. So we have this ball that is bouncing off these 4 walls, so left, right, and top and bottom. Okay, so we have that up to this point. The ball the ball keeps disappearing into the wall. Test your code at this point and you will be impressed. Now we have a ball bounce off all 4 edges of the canvas. We have another problem, however. When the ball hits each wall, it sinks into slightly before changing direction. So let me see, I haven't noticed that. Is okay, so I haven't, let me see, it sinks into it slightly before changing direction, so I don't notice it. Let me see. Oh yeah, it's sinking maybe a little bit. Okay, let me see. This is because we are calculating the collision point of the wall in the center of the ball, while we should be doing it for its circumference. The ball should bounce right after it touches the wall, not when it's already halfway the wall. So let's adjust our statement a bit to include that. Update the last code you added to this one. Okay, so we are gonna go here, and instead of having the canvas that width, it's gonna be the canvas that width. So it's gonna be the horizontal canvas that width, horizontal minus the ball radius. Okay, so it's gonna be minus the ball radius, save it, and then we are gonna have the x has to be less than the ball radius, not 0, so it's gonna be ball radius, so that, oops, and this has to be for the ball radius. Yeah, it doesn't matter because we are changing both, but it has to be for both, for the horizontal and the vertical. So now we updated the vertical of the y axis. Now let's update the x axis, so minus the ball radius, and the sum of the variables x and the x has to be less than, not 0, but the ball radius. So semicolon at the end, and let me see if the code is right. So with minus ball radius, so we have that. Okay, yeah, everything is fine. So let me see if I save it. Okay, it's already saved. Let's check it out, and let's make this one, oops, let's make, okay, maybe like that. And yeah, oh yeah, I was right, I was sinking a little bit, so but now it's, yeah, now it looks pretty good. So it's moving, it touches the bottom, it goes up, left, down. So yeah, it's bouncing off the wall. So yeah, that's pretty cool. Okay, when the distance between the center of the ball and the edge of the wall is exactly the same as the radius of the wall, it will change the movement direction. Subtracting the radius from one's edge's width and adding it into another's give us the impression of the proper collision detection. The ball bounces off the walls as it should do. So compare your code. Let's again check the finished code for the Spark again that you have, that you got, and have a play. So again, this is the this is the JavaScript code that is included in this web dev DAX, but also you have the GitHub repository, and you can check out the code in both of those. Now try changing the color of the ball and random color every time it hits, so you can play around with that. But yeah, this is pretty much all that we have for the game development, bounce off the walls. And this is our final product pretty much, and you refresh it, so the ball is bouncing off the 4 walls.